During the hot days of the summer, there's really not a whole lot in this world that's better than a wonderful ice-cold drink. In fact, the only way I know of to make such a thing better is to pair it with an awesome, high-quality, vintage electric fan to help you keep your cool. And while opinions are certainly divided on the matter, I am also a big fan of air conditioning systems, both central and otherwise, because they do such an awesome job of cutting the positively wretched humidity that we are saddled with during the summer here in Illinois. Hello there, everyone. UXW Bill here once again. I could certainly make videos talking about the wonders of cool drinks and central air conditioning systems, but today I'm going to be making a video talking about an electric fan, a very special electric fan. Some of you may remember a couple of years ago when I made a video talking about a fan that looks very similar to this one. In fact, at a quick glance, you might mistake this fan for the one that was discussed earlier in that previous video. That fan in the previous video was a very high-quality Panasonic desk fan. Still works great to this day, even though the exterior is a little bit rough. But it had a very nice feature added to it in the name of safety. If someone were to walk up to the fan grill and touch it or try to contact the spinning blades with their fingers, the fan had an electronic sensor that would shut off the motor and allow the blades to coast down to a stop. Well, back when I made that video, I mentioned that these fans are very rare and that the only ones I'd ever seen were the ones that had been purchased new by other members of my family. This is the second of such fans. I came to know at a later time that there were actually 3 of these fans, 2 of them in the 12-inch size, such as this one and the one that I've talked about previously, and then another slightly smaller one whose current whereabouts are unknown. I've also come to know of at least one person on YouTube who has a similar fan. A user by the name of Subie, S-U-B-I-E, Steve, posted a video about one of these fans, and if you search for it on YouTube, I'm sure that you can find it. Well, as previously mentioned, the first of these fans that I made a video about is in a little bit of a rough condition. It's had a lot of use over the years. It's been loaned out to people, knocked around, that sort of thing. But electrically and mechanically, it still works absolutely great. And electrically speaking, this fan works very well as well. You turn it on and air starts blowing out of it, and it works just amazingly well, except for one thing, and that's the magic stop functionality. I tried to troubleshoot this fan a number of years ago, but I never got very far with it, and I finally decided to leave it alone because, well, it worked just fine as a plain old desk fan, and it wasn't very likely that anyone was going to actually stick their fingers in the fan. However, most recently, this fan wound its way back to me from my grandfather's house because my aunt, the one who drove the Volvo, claimed that it didn't run at all. So I decided, okay, I'd better finally take a look at this, and in my typical way of doing things, it sat around on the kitchen floor for the longest time before one day my mother plugged it in and discovered that it seemed to work just fine. And what's more than that, the magic stop functionality had also returned to working order. I cannot possibly explain why. I don't know if there's components in this fan that have drifted over time or just what the story might be, but I do know this. While it's working, I'm going to go ahead and take advantage of the moment. So let's go ahead and take a look at this fan and its features and controls. Let's go ahead and start our tour of this fan right here on the ground floor with a look at the base plate and control panel. For those of you who are familiar with my previous video about the other Panasonic Magic Stop fan that I happen to own, you'll see there's a lot of similarity here. Panasonic did not get carried away with major changes to this design. They kept the color scheme and the location of the major operating controls the same. They just minorly updated the styling a little bit, and for some reason decided to add a designation above the operating controls that says fingertip air control. Perhaps that was intended in some way or in someone's mind to make the purpose of those controls much more obvious, but I really rather doubt it because operating an electric fan of any kind is not exactly rocket science. By the way, if you have not watched my previous video about the other Panasonic Magic Stop fan that I have, you might want to go ahead and pause this video and look the other one up because there are some differences in the way that these two fans operate, and invariably there'll be some things that are mentioned in one video but not the other because I'm about the furthest thing from perfect that there is when it comes to making videos. Getting back to the subject and looking over here at the left side of the base plate, you can see that there is an updated version of the Magic Stop logo as compared to the other fan. However, one thing remains the same, and that's the inclusion of the phrase solid state. Now, back when I made my previous video about the other Panasonic Magic Stop fan, the phrase solid state was of some confusion to certain members of the viewing audience, which probably says a lot about their age. And while it's certainly not the subject of this video, if you happen to be confused about its meaning, I'll go ahead and give you a little sidebar to offer a better understanding of what the phrase solid state means. Back in the earliest days of electronics, the active components in a circuit were vacuum tubes, or valves. Now, there really wasn't anything wrong with vacuum tubes, but they weren't quite perfect. Tubes do eventually wear out over time. They take up a lot more space compared to modern electronic components. They tend to run hot, and it also takes them a while to warm up and start doing their thing, because in order for a vacuum tube to work, the so-called filament heater inside it has to warm up and start emitting electrons so that the tube can begin to do its work in a particular type of circuit. By comparison, transistors, which were introduced in the mid-1950s, start working instantly, waste a lot less power as heat, are much more conducive to battery-operated designs, and are much more reliable. As you can imagine, the marketing people for anyone who was designing circuitry based on transistors felt that they had to find a way to make it known to the electronics buying public that their product contained what they considered the superior technology of transistors, and that is what the term solid state means. Basically, that a device has transistorized circuitry, and this fan definitely does. The transistorized circuitry comes in the form of the detection circuit that tells the fan to stop running if someone has touched the grill. Likewise, when integrated circuits containing many hundreds or even thousands of transistors became common in electronic devices, it was not at all uncommon to see the designation IC, or IC solid state, such as in the faceplate of this Scott tuner. So hopefully that explains, for those of you who were confused about the meaning of the term solid state and even integrated circuit, exactly what those designations mean on a particular electronic device. Let's continue our tour of this fan. Go ahead and look on the side here. As with the previous model, this fan contains a sensitivity switch for the Magic Stop function. In the owner's manual for one of these fans, a great deal more information is given about the function of this switch. Basically, if the weather is exceptionally damp, the fan may not satisfactorily detect touches and stop operating in time or even at all. If that should happen, you can slide this switch to increase the sensitivity of the Magic Stop circuit and cause the fan to stop running. We'll go ahead and turn the fan around to the back side here. You can see that Panasonic actually moved the information plate on this fan. It says on the back that it is an AC desk fan with a blade diameter of 12 inches. Since this video was made, as I mentioned during the first segment, I have come to know that there is a third fan of this type in my family. However, its whereabouts are unknown. The only thing I remember clearly about it, and I think it too had the Magic Stop functionality, was that it was a slightly smaller model. This is the Panasonic model F-1252, running from 120 volts AC, a line frequency of 60 cycles per second, or 60 hertz, and a current draw of 0.7 amps. It was made, of course, by Matsushita Electric Industrial Company Limited, the company that we know today as Panasonic Corporation, and naturally it was made in Japan. And like many other electric devices, this fan was UL tested for safety, and that is why it bears an Underwriters Laboratories badge on it, if you're unfamiliar with that. Though again, that's not the subject of this video. One feature of these fans that I really didn't touch on at all in the previous video about the other model is the retractable cord. Now, the cord does not have any kind of a spring-loaded retraction system, but in what is a very handy feature, you can feed the cord in through this guide until it is all the way stored inside the fan. Thus, when you carry the fan with you, you don't have to worry about bundling the cord up or it getting tangled in anything and potentially tripping you. It's a very nice feature, and just like the Magic Stop functionality, is certainly something that you will not see on a modern electronic fan. If you are familiar with my previous video about these fans, you will notice there's been some cost cutting on the part of Panasonic here. This is not the only thing that has changed. Unlike the previous fan, where the entire base plate assembly is made of metal, this one is made of plastic. Only the bottom plate portion of the assembly is actually made of metal. Looking up on the stem of the fan, you can see that there's either an improvement in engineering or maybe some cost cutting here. I'm really not sure, to be honest. On the other fan, you can adjust the angle at which the airflow is directed by loosening a screw type knob here at the back side of the stem, and that allows the fan in turn to move up and down. This fan either updates or makes the design less expensive if you're feeling charitable, if you're feeling uncharitable, I'm sorry, by removing that knob that formerly locked the fan in place and using the weight of the fan and balance to allow you to move it such that you can direct the airflow wherever you want it to go without having to loosen the screw at the back. So whether or not that was cost cutting or an improvement in the engineering, I don't know, but it is definitely a difference in the design between the two fans. I'll go ahead and pop the grill off here so you can see another example of some cost cutting from Panasonic. I'm not sure I can do this one-handed. I may have to stop the camcorder in order to do this. I certainly did on the other fan. I'll go ahead and see here. There is a reverse threaded knob that is used to hold these blades on, and the reverse threading is very much deliberate. It's threaded the opposite of the direction that the fan blades would normally turn, so that the action of the fan and its starting and stopping over time cannot serve to cause this knob to come loose and allow the blades to go flying off the fan. If the front cover was on the fan, however, that really wouldn't be a problem apart from the alarming noise that it would make. Now, the blade set can be removed by simply lifting it off here. I was actually able to do it single-handedly. And you can see that the motor design in this fan is pretty much the same as compared to the previous model, but there is a key difference here in the blade set, a little more cheapening on the part of Panasonic. Where the blades for the other fan actually contain a metal insert to give them greater durability, this blade set is completely plastic, and unfortunately that means if by some chance you did not happen to get these blades on tightly, that plastic could be chewed up, shattered, or cracked by action against the shaft of the motor here if it's not tightened down securely or tightened up in the proper way. So if you find one of these fans, that's definitely something to be aware of, because it looks like they did at some point cheapen the design a little bit. Go ahead and make sure I've got the blades back on the shaft here correctly, and then I'll go ahead and fasten this knob. In an interesting change from the other fan, this fan's retention knob has printing not only in English but also seemingly in Japanese. The other fan, as I remember it, has a retaining shaft that is printed only in English. Go ahead and put the fan grill back on here, which I may or may not be able to do one-handed. It's looking a little grim for the home team right now. We'll go ahead and give this the old college try here. The hard part is lining up the little pegs to make sure that the grill fastens properly, and then getting all these little wings on the side fastened correctly. But once I've done that, the fan is once again ready to run. So go ahead and turn it on. And despite the changes that have been made in the design, there's really not much that's changed on the motor front. It still sounds very much the same. So here's a little demonstration of the fan's spin-up sound. Sounds a little rough, but I just went through and gave this fan a complete oiling and a very thorough cleaning prior to making this demonstration video. I also have no idea why it's sped up like that at random. It's done that from time to time when I was tinkering with it earlier, and I don't know if maybe the run capacitor for the motor has a little bit of a problem, maybe it's a little bit leaky, maybe it's a little bit out of practice. The line voltage around here is nowhere near that kind of unstable that would result in such a marked change in the motor's rotation speed. So go ahead and shut this fan down here, and you can watch it spin down. The bearings on the motor are in very good shape, though not quite as loose as the ones on the other fan. Go ahead and pause the camcorder here, and then I'll show you another key difference in this fan's design, and that is the aspect of the magic stop functionality as compared to the other fan. Okay folks, I've really outdone myself this time. Not only have I gone and gotten the original Panasonic Magic Stop fan that I made the first video about, but I've set them both up side by side here on the electronics repair pool table of science, and I've got them both running at high speed right now. I'll tell you what, I'm standing right behind these fans just outside of the camera's field of view, and it's like I'm inside a wind tunnel right about now. This is probably the closest I have ever been to being a cool person. I know, that was a bad joke. I'm not done yet, though. I haven't stopped just yet. I even went to the trouble of putting the camcorder up on a tripod for this particular demonstration, where the big difference between these two fans will be revealed to you shortly. I've even gone to the trouble of very scientifically trying to figure out where to put the camcorder such that it had a view of the fans, but that the microphone wouldn't have a face full of wind. Now we'll see how successful I was when it comes time to edit this video, because I have no idea how well that's worked out. You may hear nothing but fans blowing at the camcorder right now, but I did try at least. Anyway, the difference between these two fans is more than just cost cutting and slight updating of the style. Back when I made the first video, one of the commenters mentioned a variation on this Magic Stop fan design that actually supposedly fired a pin through the rotating motor so as to stop the blades immediately. Now that's an interesting revision to the design, and it's something that the first fan here does not have, nor does the second one. But the second fan does appear to have a change in its design that would increase its safety when a child or someone who has had a leave of their senses goes to stick a finger inside the fan grill and try to get themselves bit. I'll go ahead and touch the first fan here, and as you can see, it powers down and stops spinning, just very gradually, very gently. And if I release my finger from the outside of the fan grill, it starts right back up and starts running again. I'll go ahead and turn this one off because I don't need it any longer for the purposes of this demonstration. And then I'll go ahead and touch the grill on the second fan. And watch this. You'll notice it comes to a stop immediately, or very close to. And at first I thought, well, maybe that fan is designed such that it fires a pin into the motor, but I don't think so. I think you would tend to hear that. I think that would make a very loud metallic, or excuse me, even a clicking noise. I think this fan is actually using electrical braking, that is to say, applying reverse polarity current to the motor and causing the blades to stop that way, which is definitely a very interesting improvement in this particular fan's safety. I've gone ahead and removed the dust cover from the motor assembly on this fan, a task which was made greatly easier by the fact that whoever worked on it previously, which almost certainly was not me, did not bother to replace the screw holding this cover in place. It really kind of dawned on me that after I had shot the previous segment of this video demonstrating how this fan has an electrical braking function built into the motor, that what I said about it might not be correct. After all, this is an AC motor, and unlike a DC motor where you can simply reverse the polarity of the input to the motor to reverse its direction of rotation, alternating current already does that 60 times a second, so the motor has to be designed a little bit differently, and I think you actually have to rearrange the wires feeding the windings in an AC motor that's intended to be reversible in order to make that happen. If I'm completely off the wall here, I beg your forgiveness, and I hope for your gentleness in correcting any errors or misunderstandings that I may have here, because there could be quite a lot of them going on. I think that this motor may actually have a separate winding that is used for the braking function whenever the finger sensing function is tripped. And the reason I say that has to do with the fact that whenever this motor is turned on and running, I'll go ahead and start it up here. You can hear it start, and you can see the armature turning inside the coil there. Whenever I trip the finger detection function of this fan and it stops, there is a momentary and moderately loud, actually, hum that emanates from the coils inside this motor somewhere whenever this fan stops. I don't know if the camcorder will actually pick it up, but I'm going to go ahead and touch it and see if it happens to do so. I didn't really hear it there. Let's go ahead and try speeding up the fan. It'll take a moment for the circuitry to reset itself. I've got this fan kind of awkwardly situated down here, pointed at that server case, so it was probably just reflecting most of the wind noise right back into the camera. Let's go ahead and try this again. Put the camera up near the motor, so maybe if there's any chance of your hearing it, you will hear it when it happens, and then I'll go ahead and touch the fan here in just a moment. I would highly advise not touching anything if you ever run a fan like this, because you could get quite a shock, and that would tend to reduce your enjoyment of vintage electric fans, now wouldn't it? I still don't think you can really hear it, but believe me when I say that it is actually there. Well, that's about everything I can think of to say as concerns this second Panasonic Magic Stop electric fan. I thank you for taking the time to watch this rather protracted video. I will appreciate your most gentle correction as concerns the operation of the motor if I have the details majorly wrong, and of course, as always, I will beg your forgiveness, and if you have a comment, you should certainly feel free to leave it.